Hello guys, in this module 3C we are going to learn about electrical power. Now look here, when it comes to the electrical power, I hope you people have already learned in grade 9 that power is nothing, it is work done upon time. So here also when we define the electrical power, it says rate at which electrical energy is consumed. So P is written as, the power is written as E over T. Even if you wanted to write here W, it is perfectly fine. So power can be written as E over T, or power can also be written as work done upon time. Now one thing which you people need to understand over here, if you wanted to write that what exactly is the work done over here, it can be also written as P into T. So for energy you can take the symbol as E or you can take it as W. But what I want you to understand over here, that in this case when I write power is equal to work done upon time, I have seen in the previous module that my voltage is written as work done on a charge. Now this work done which I have over here, it can be written as VQ. So in case if I plug this value of work done over here, it will look like that power is equal to voltage into charge divided by T. Now this charge flowing per unit time, I hope you people also remember this is nothing but current. So your power can also be defined as voltage times current. So these are the various formula of power which you can see over here, and definitely we are not interested in the mechanical definition over here which is work done upon time. What I would suggest, you should remember the power formula over here in terms of voltage into current, or you can also remember in terms of voltage into charge over time. Now if you see the next part over here, but before that, the SI unit of power, let me tell you, it is watt, and as you can see it is energy per unit time, and energy is always written as joules and denominator is always written as second, so watt or joule per second, but we will definitely use the watt more frequently. Now when it comes to the commercial unit of energy, we need to understand that everybody gets electricity bill at their home. They don't write some very complicated unit over there, because we need to simply understand when it comes to the SI unit of energy, it is joules. But in commercial unit, as if we write that particular value, it is going to be a huge value. So what we have done, we have simplified that in a commercial bills, the unit will be taken as kilowatt hour. Now what you need to understand over here, commercial unit or 1 unit, suppose if you get an electricity bill and it says 80 unit, what does it mean? Means it is 80 kilowatt hour. So how do we actually get this relation over here? If I have to show you, I just now told you when you say 1 unit, it is equal to 1 kilowatt hour. Now if you wanted to see that how does this value will look like in terms of joules, because kilowatt hour is nothing, it is joules. Let me break it for you. 1 kilowatt is nothing, it is 1000 watt. 1 hour is nothing, it is 60 minute. That means if I write watt as joules per second, I don't think there should be any problem, both are the same unit. And here again minute, 1 minute is equal to 60 second. So this is how it will look like. Now this second at the denominator and this power is going to be get cancelled, so you can see 1 unit, it might look like 1 kilowatt hour, but if we simplify the unit on the right hand side, it look like joules only. So what I will see over here, 60 into 60 is going to give me 3600, and you have 1000. So this is how it will look like. So if we write in terms of 10 raised to 3.6, and you have 2456, so I have shifted 6 digit. This is going to be 3.6 into 10 raised to 6 joules. So you can see that 1 unit or 1 kilowatt hour, what does it mean in terms of joules? It means it is 3.6 into 10 raised to 6 joules of energy somebody has consumed. Now when we'll go to the next part over here, which is effect of electric current. Definitely there are various effect of electric current. One is magnetic, which you're going to see in the next chapter. Chemical, you might learn in chemistry, but here in which we are, the one particular effect in which we are interested is heating. Now how exactly this heating effect of electric current can be seen? We know that because of flow of current, the electrons are going to have some kinetic energy, and these electrons are going to be collide with the number of atoms which are present in a material. So this collision which is going to be happen between electrons and the atom is something which is going to be lead to what? Heat. So if we actually see according to law of conservation of energy, if the amount of energy supplied at the input and the output, they are not same, they are different. What does it mean? Definitely there is some amount of energy which has been wasted in between, or some amount of energy might have resulted in a heating effect. So this loss of energy which is happening over here, we simply call this is going to be give us heating effect. Now we have a formula for the heating effect also. So what I'm going to do over here, when you say Joule's law of heating, we can simply read this particular statement: the heat energy produced in a conductor is directly proportional to square of current, resistance, time through which the current is flowing. But what exactly it is? As we have seen in the previous formula, we have written that power is equal to work done upon time, or you have also seen that power can be written as voltage into current. But I want you to focus on this particular formula over here, work, because if you see the SI unit of heat is also joules. So if I have to write work from here, it is simply means power into time. That means if I write power in terms of voltage into current, this is how this particular value will look like. And let me tell you, this work done, I might be writing W, but this can also be written as H, which is my heating effect. If you use your Ohm's law over here, which is V is equal to IR, so the very expression will look like this, where you can multiply I into I, it will make it I square RT, and this is basically the heating formula which look like. Now if you actually read this particular Joule's law of heating, you are going to find the same term, where you can see that heating effect, if it is depend on something, the value depend maximum on the current, because heating is directly proportional to square of current. So in any circuit, if you wanted to reduce the heating effect, the very first thing which we should do is reduce the flow of current through it. Second thing is the heat is directly proportional to resistance, and third factor will be definitely how long, means the heat is directly proportional to the time also. In this case, the formula which will remain is I square RT, but in some cases we will also use the formula VIT depending on the information which has been given to us. So this is how we actually understand the Joule's law of heating over here. Now if we have to see one particular question based on this, we can see that in a house 260 watt electric bulbs are lighted for 4 hours and 300 watt bulbs for 5 hours every day. Calculate the energy consumed in 30 days. Now look here, first one thing which we need to do, the formula which we have is energy consumed is power into time. We know that if you talk about the first instrument which we have in a house, 2 means we have 2 electric bulbs, and if you see the power of these electric bulb is 60 watt, and then we have written the value of T because they have been running for 4 hours. So if I write my E1, this is only for the electric bulb. Similarly, I have to calculate for the other appliances also. So we have 300 watt bulbs for 5 hour also. But before that, I will do this calculation. Please make sure that this value I have written 2 into 60, which is 120 watt, and this is 4 hour. This product gives me the value in terms of 480 watt hour. We'll go for the second instrument. We have 300 watt bulbs. So number 300 watt, and they have been running for 5 hours. So this is how it will look like. If we simply do the calculation for this particular part, it comes out the energy consumed by this particular instrument is 1500 watt hour. Now what we need to do, we will simply add up both the energies. So we will get our answer as 480 watt hour plus 1500 watt hour. But I told you that commercially we always calculate in terms of kilowatt hour. So what we are going to do, we will simply divide this value by 1000. When I take 1980 watt hour, if I divide this particular value by 1000, I'll get this particular energy in terms of kilowatt hour. So what I will get, I'll get 1.98 as the energy which I have consumed. So energy consumed in this particular house is 1.98 kilowatt hour, or you can say 1.98 unit. But this is for a single day, and we need to calculate the amount of energy consumed in 30 days. So in the end, what I'm going to do, I'm going to simply multiply this particular answer with 30. So my final answer is going to be 59.4 kilowatt hour, or you can say that the amount of energy consumed in 1 month is 59.4 unit. Thank you.